right, ladies and gentlemen, so today we're going to start talking about something called bivariate data analysis, and that's where we're looking to see whether there's a relationship between two variables. So bi always means two, right? So we're seeing, is there any type of relation? Sometimes it's called a correlation, sometimes it's called a causal effect, and we're going to see that in a little bit. So to do these, we're going to take a look and see if there is, we're going to create something called a scatter plot. And the reason it's a scatter plot is because these are not going to line up, these points are not going to line up nice in a straight line or even a curved line. Depending on the situation, they're going to be a little bit scattered. So we're comparing here the low temperature for a day and the high temperature for a day, and we want to see if there's a relationship going on. So these are our x and y values, so we're going to plot these. So 26 and 49, so that's about here, and 28 and 50, 30 and 57, 32, sorry, I'm not talking, I'm just reading the data points here. 35 and 58, 37 and 64, 38 and 66, 41 and 63, and then 45, 245 and 72. Okay, so again, you'll see that they don't line up in a nice straight line, but what we look for is there some type of trend? Meaning, can we approximate a line? So that's what it says here, draw a line of best fit. And in order to draw a line of best fit, it has to come close to as many data points as you can. So I'm actually going to use my little line tool here. So when I do this, all right, I'm going to take it, I want to try to come as close as I can to as many of the points as I can. Right? So there is what I would consider my line of best fit. So I could take this line, right, and if I moved it down, oops, not that data point. If I moved, oh my gosh. Sorry, ladies and gentlemen. So if I try, maybe we're not going to move the line. If I try and move the line, it's going to give me a different relationship. So you want it to be, like I said, as close as it can be to as many of the data points as possible, and even almost splitting some of them. All right, now they want us to calculate the slope of the line by picking 2 points, and they don't have to be data points. You're going to look for where does it cross a line, right? So right there, and looks like I can maybe get another one about, I'm trying to see a good one, actually probably right up about here. So this point is 22, 4, 6, 8, 28, 54. And then this other point is our 42, 72. And I know I ended up moving my graph a little bit. So depending on where your line is and how you put it in, your slope when you're calculating it might be slightly different. But to find the slope, right, it's y2 minus y1 over x2 minus x1. That's a formula we have to know. So 72 minus 54 over 42 minus 28. 72 minus 54 is going to give me, 18. And then 42 minus 28 is 14. And if I divide those, so we're talking about 1.28. I could just reduce them and make it 9/7. I could keep it as a fraction. Use your line of best fit to estimate the high temperature for any given day, and it says illustrate your answer on your graph. So that means that you're actually going to kind of draw this in. So when I do the 42, and for me 42 is actually one of the lines, so I'm going to go up to where it meets, and I'm going to go over, so for me that was 72 degrees. Would you characterize the relationship as a positive correlation or a negative? This is a positive. Right, my line is positive because as the low temperature goes up, increases, and the high temperature increases. Okay, so there's a positive correlation there. All right, let's take a look at the next page. So two variables can have a strong relationship with one another as seen on a scatter plot, but might not have a causal relationship. And that a causal relationship exists when the change in one variable actually causes the change in the other. All right, so one thing is causing something else to change. So what we're going to do here is we're just going to take a look at four situations. Now we already know that there's going to be a correlation here. What we're looking for is it a causal relationship? Did one thing cause the other? So the high temperature in New York City and the number of water of bottle of, oh my gosh. I hope today isn't going to be any indication as to how this is going to go later. So we're looking at, let's say that again, the high temperature in New York City and the number of bottles of water sold. Yes, this is absolutely a causal relationship because as the temp increases, people get thirstier and buy more water. All right, a person's height and a person's shoe size, that is not. Just because you are taller does not mean that it is making your foot grow. All right, so this is not a causal relationship. A person's weight loss and the number of hours a person spends at the gym, yes. Right, so here it is the number of hours working out causes more weight loss. And we also know, of course, from health class that there's other factors involved, but that certainly is one of them. The years of education a person achieves and the salary that a person starts at upon entering. This is another example. All right, the more education you have, the higher the salary. Which is why it's important that we go to college. Okay, variables can have an extremely strong correlation, but now causal relationship, sorry. This is often the case when there's a third variable that causes both. So when I take a look at this one, we're talking about the number of firefighters needed at a fire and the amount of damage done in dollars. So are the data positively or negatively correlated? How can you tell? They're positively because they are both increasing. Does the number of firefighters cause the damage done to the house? No. Right? Just because there had to be more firefighters there does not mean that the firefighters are the ones causing the damage. So what is that hidden variable, that lurking variable? It's the size of the fire. Right? If you have a really big fire that's gotten out of control, you need more firefighters, which means there's going to be more damage. So this is really the one that's causing both of those things to increase. All right, any questions? As always, and I'm sorry for all of my not being able to talk today, I guess. Have a good day, guys.